Hello class, Mr. Ullman here, and I wanted to continue on with a look at carbon, and this time though I wanted to skip a little bit past some of the specific data in terms of CO2 that you'll certainly spend a lot of time on in class looking at, and focus on what are some of the consequences of the enhanced greenhouse effect and the impact on ecosystems, particularly the Arctic ecosystem, of a warming climate. Now, when we think back to our previous study of biomes, there are two factors that ultimately determine what the biome will be. The amount of precipitation that's in an area and the temperature. Now, if you look at the graph at the top left hand side of the screen here, this shows all of the biomes on a single graph broken down based on what the temperature and precipitation is. And you can see that the range in terms of temperatures is in some cases fairly small, so that a change of a few degrees could mean the difference between one climate type and another. Now, the Arctic ecosystem falls on the extreme end of both the dry and very cold tundra. And in the tundra, and in the Arctic in general, the temperature swings have been recorded to be much greater than those near the equator. So a global temperature increase of 1 degree Celsius might mean a temperature change in the Arctic of 3 to 4 to 5 degrees Celsius. And that much of a change, as you can see on the graph, could certainly push some areas from the tundra into one of the other biomes. When you add to that the fact that the increase in temperature also changes the amount of precipitation based on additional evaporation that occurs, then you could certainly see that there's likelihood of there being some type of change in terms of climate, particularly here in the Arctic. So as we look specifically at the Arctic, we're going to see that species are going to shift. Those species that are dependent on certain type of vegetation, as the temperature changes and this temperature warms, the type of vegetation that can grow in an area will also shift. So we should see some population shift from one place to another as they are gradually moving, in the case of the northern hemisphere, further north in order to kind of move along with that shifting temperature. When we look at a polar ice climograph here on the left and then a subarctic climograph on the right, so this is showing the precipitation at the bottom and showing temperature in the center part of the graph. You can see that the red line represents maximum temperature, the blue line represents minimum temperature, and the bars represent what that mean temperature is going to be. Now, in a polar ice climograph, in the extreme within the Arctic Circle, you can see that the zero line for temperature, that for the majority of the year, those normals are going to be below 0 degrees. You can see that in those summer months in the subarctic, those temperatures are getting above, and you can see what the annual mean temperature is for each. In the Arctic, negative 16.2 degrees, and in the subarctic, negative 11.5 degrees. So if there's going to be a tremendous shift in the global temperature, that's going to push some of these temperatures, particularly in the polar areas, up so that they are up above freezing for a greater period of time during the year. And that's a very significant event in terms of looking at polar ice. Every year, the NOAA, which collects lots and lots of data about oceans around the world, does a lot of work in terms of looking at the North Pole and the Arctic region to be able to study the ice and the habitat of all of the areas within the Arctic. There's some older data here. I wanted to switch over and take a look at their website to see their most recent report card for some of the most current data. Go back here. There we go. on sea ice. Now, if we look back at 2002, this picture shows the extent in white, shows the extent of sea ice during September 2002. And September is the month when sea ice has retreated the most. So there is the least amount of ice in the month of September out of the entire year. The purple line shows the median ice edge. So if we look at kind of the average extent of that ice, and then look by comparing that to the shaded area in September, we can see to what extent is the ice melting each summer. And so, you can kind of take a look. We have Greenland, North America, and Asia, and you can see where it is that ice is in comparison to the median. Now, when we go back, we'll zip ahead a few years. We can look at 2008, and here you can see that, there's particularly on the edge, when we look at off the northern coast of Russia and off the northern coast of Alaska, that a lot of that ice, a much greater percentage of it, has melted during the summer months. And then as we look ahead, 2012 really was one of the worst years in terms of sea ice melting. Here, not only off the northern coast of Alaska, but extending much more through Canada, and then over onto the northern Europe side, much more of that ice has melted and really only remaining stable over the North Pole and extending over towards Greenland. So when we take a look, when you just compare and you see the amount of sea ice here in 2002 versus the amount of sea ice here in 2012, you can see that the trend there is fairly consistent in terms of there being less and less sea ice per year. Now, obviously that is not, that's a trend that has some variance to it. You see 2006 versus 2007, there's a big difference there, but there was more ice in 2008. Very little ice, that was a record low in 2012, but more of that ice was maintained throughout 2013. And so this graph here is giving you a little better picture of how it is that the amount of ice is changing over time, because you can see that year after year it's going up, it's going down, it's going up, it's going down. We can make predictions ahead into the future. But again, when we look at the trend line here, we can see that it is clearly sloping down, and that we would expect to see more and more sea ice disappearing during the summer months in the future. The NOAA also produces a report card, which is really helpful in terms of providing some great info on what are some of not just the climate, but also the impacts on life, impacts on the geology of the land masses within the Arctic. There is a nice summary video here, which I'll link at the bottom of this page, so look in the comments section, or look in the description section for that link, and I really recommend you take a look. It's just a couple of minutes, but it gives you, it shows you some of the highlights from their previous year report card. The 2013 report card is obviously not out yet. But one thing I just wanted to highlight from that is that about the Arctic. Interesting to be able to see how is it that the change in temperature really impacts a particular species. And here, if we look at the Arctic fox, it is a fairly small animal, but it is quite remarkable because it is an animal that lives entirely in these polar regions, in the tundra, but it does not hibernate. It's active throughout the year, and it simply adjusts to the climate through biological means. It puts on about half of its body weight in fat during the fall, and has an extremely efficient coat of fur that insulates their bodies from the cold. And so they also dig, and so they dig dens into the snow to be able to have some protection from the elements during those times when it's extremely cold. And these animals are carnivores, and so they are hunting mostly rodents, because this is a fairly small fox, and one of their primary sources of food are the lemmings. And their population tends to fluctuate a lot because when there's more food available, when there's more lemmings in a year, when there's more of those rodents running around, then the foxes will reproduce very, very quickly. Within a single season, there'll be a big increase in the number of foxes that will reproduce. But in 2012, the population of foxes took a big hit, and an area in Scandinavia where there were traditionally something in the 10 to 15,000 foxes population in the range of 10 to 15,000 individuals. Now there are less than 100. And that change is mostly due to competition, because as the Scandinavian area has gotten warmer, the growing season for plants is longer, so there's a greater variety of other animals that are then moving north into their territory. And the new competition that's coming in is the red fox. Now the red fox also has a global distribution, just like the Arctic fox. Obviously it has a difference in coloration, and from that color you can tell that this is not an animal that lives in the tundra. It's not used to living in a place where there's snow all year round. However, during the Arctic summer, the red fox is moving north into that territory and is competing for the same food resources because the summers are now warm enough for this fox to be able to still survive in that cold. So the red fox is much bigger, sometimes twice as large as the Arctic fox, and so they're a pretty formidable opponent. And as we know from the competitive exclusion principle, if you have two animals going for the same source of food, something needs to give. And in this case, the red fox is out-competing and is causing a decrease in population of the Arctic fox because the red fox is a better hunter and is better adapted at being able to get some of those sources of food that the Arctic fox relied on. So we can see there that a shift in temperature shifts food sources, and so we get more competition between some of these organisms. And for the Arctic fox, there's nowhere further north for them to go, so they really don't have any other recourse other than to die out. If we suspect that there's going to be a significant change in climate, we know that any change in climate is going to have a big impact on ecosystems. Not just the Arctic, but all ecosystems around the world, because as the temperature changes, populations are going to shift, species extinctions will rise, and there's probably a lot of unintended and unforeseen consequences that are going to happen. Now, there is ongoing debate in the minds of public. America is a great example because there's still a very large percentage of Americans that don't believe that the climate is changing or don't think that humans have anything to do with it. If there's a chance that any action may do harm to the people or the environment, it should be stopped until proven safe. So if we look at the actions here, so the actions here are our burning of fossil fuels. Okay, because we burn fossil fuels, put more CO2 in the atmosphere, that CO2 enhances the greenhouse effect and raises temperatures. Okay, if that's even possible, which it certainly is because we've recorded those changes in the previous years, then we should make effort to stop that action until we know and can provide more sound scientific evidence to really show what the exact consequences are going to be. Now, the burden of proof on that should lie on the people who are doing the harm. So on those, on the people, on the organizations, on the companies that are primarily responsible for releasing that CO2 into the air. Okay? Now, in terms of places in the world, it certainly would fall on nations like the United States, which are responsible for a great amount of the CO2 going into the air, to be able to fund some of the work to do that. And there certainly also should be some effort put on the parts of oil companies, of car companies, of major manufacturers that are releasing a lot of those gases into the air to be able to prove that what they're doing is not going to harm our environment. Because that short-term good that comes from the economic benefit of the work of those electrical companies and those drilling companies will certainly be outweighed very quickly if we see some of these predicted changes in climate. So here's where we get into issues of what is sustainable, what fuels can we use, what types of activities can we take part in that a large population of humans could all continue to do for many years into the future without seeing any of these irreversible changes to our climate. And certainly our actions right now are not within that realm. Our actions right now certainly extend beyond what is sustainable, and so we need to consider, is this something that is this right for us to do, knowing the impact this could have on future generations? And that's a question that will bring up certainly a lot of moral and ethical issues, brings up discussions of trade-offs, what are the benefits, what are the and what are the harms to ourselves and our way of life, what are the changes, what are the costs associated with making those changes. But it's a discussion that needs to be had because, again, our goal should be not to harm, to do no harm to ourselves and to do no harm to an environment that is going to have a permanent impact.